good afternoon for you guys. So, myself Omkar Arun Matkulkar, and today I'm going to talk about neural network. So, basically, first neural network was like invented in 1958 by psychologist Frank Rosenwald, and it was called as a perceptron model. And the intention for developing that model was his idea was how human brains actually predict the visual data. So to learn that, he started researching and he developed this model, and the image is below over here. This is the basically first perceptron model that he developed. And if you see today's world, so the chipset is very small compared to this. So this is a small chipset where we can do neural network task in like very small way. So why we are learning this? So it reflects the behavior of human brain, and it able to recognize pattern and solve common problems in the field of artificial intelligence, machine learning, and deep learning. Before jumping to neural network, let's understand this jargons of artificial intelligence, machine learning, deep learning, and neural network. So, if you see in this image, we will think this neural network as a set of Russian nested dolls. So, Russian nested dolls are going one inside each other, and they are the essential component. They are very important of each other. So similar to that, machine learning is a subfield of artificial intelligence, and deep learning over here is a subfield of machine learning. And over here, neural network, it makes the backbone of deep learning algorithm. So next is how what are neural networks? So neural network, also called as artificial neural network, or a simulated neural network, and they mimic human brain like algorithm. So neural network, it mainly consists of an input, weight, bias, or bias we can also call it as a threshold, and an output. So this is like a human brain has different neurons which is interacting over here. Similarly, scientists also try to develop that functionality in neural network, like it by connecting each node, different nodes, and giving us an output. So, how does a neural network structure look? So, basically, it has multiple inputs. It has different nodes, layers, multiple hidden layers, and an output layer. So, there are multiple hidden layers in it, and we have an output layer. So, each node has weight and a threshold, and has an activation function. So once the input and weight have been decided, it passes through each and every node. And once that input and weight, after multiplication and adding with the threshold, if that node is above that activation function, that node gets activated, and that node sends signals to another node. So the nodes gets activated and the data is sent in one another direction. Otherwise, it doesn't send the signal to the next node. So normally, neural network it depends upon trained data. So as uh, so more the data has been given to the neural network, the accuracy will be more higher, and the learning algorithm will be more finely tuned if you give more data to the neural network. And this model can able to predict more accurately in computer science or artificial intelligence. Tasks such as speech recognition or image recognition, which will take like minutes compared to human identification over here. One of the best example is Google search algorithm, which gives you instant results. So how does it works? So we'll think each individual node as a linear regression model, and it consists of input data, weight, bias, and an output. The formula which will look like this: y is equal to summation of weight into input plus bias. And once this input layer is determined, weights are assigned accordingly to those input. And then after passing those weights, if that threshold, if the calculation is above threshold, the node will get activated. And this passing of data from one node to another node is called as feed forward neural network. Then this is like how one single node will look, and how inputs and the weights are passed to single node. And once the addition or the subtraction will be done over here, and then the activation function also inside this one single node. And once this activation function is get activated, means like this is satisfying this activation value, the output is passed through over here. And now let's consider one small example where we are like predicting for one node, and over here we are using Preceptron kind of model to predict the output. So first is like the surfing example which I was talking prior, and like over here. So shall we go for surfing? We will consider yes and no. So before going for surfing, we will consider some factors like is the waves are good, is the place is too crowded, or is there any recent shark attack? So accordingly, we have assigned them values like x1, x2, x3, and the values like 1, 0, 1. Since the wave is good, we have given it as a 1, and the crowd is not there, so we have given it as 0. And the shark attack has been, there is not a shark attack, so we have given it 0. And we have assigned weights accordingly. So how the weights have been assigned, the as the values are more important, the weights are assigned accordingly. So over here we can see the weight of 5 and 4. So for waves we have given the weightage as 5, and for weightage W3, which is for the shark attack, we have given as 3. So over here weightage 5, which represent that the waves are very important. Without waves, we can't do surfing. So we have given over here the weightage 5 important, and weightage 4, if there has been recent shark attack in the sea, so we won't go. So we have given the weightage over here as 4. So we over here considering for one node, this example, simultaneously there will be many different nodes in a hidden layer, and each node will have different weightage. So all the nodes will get different weightage for each and every value, and those nodes will get activated if the if the output is above a threshold level. So over here we are considering as a perceptron level. So we have considered over here threshold value of 3, and our output which is coming above 6, above 3, sorry, above 3, and which is coming 6, which is above our threshold value. So the activation function over here will get activated, and we will get an output that yes, we should go for surfing, that is yes. Then yeah. So normally in neural network, prior we were discussing about perceptrons, but normally in neural network, feed forward neural network, we used sigmoid curve, sigmoid neurons, where sigmoid neurons have a range of between 0 and 1. So the values of the output will be 0, between 0 and 1. And in perceptron, the value will be either 0 or 1. In sigmoid, we have proper a smooth curve. And but in perceptron model, we have only 0 and 1. Where in graph we can see, like one of the example I have considered, like a salary person who can buy a car or not. So where we can see that uh, person having salary below 50, they are not able to buy a car, but person who is having salary which is higher than 50,000, they are like can buy the car over here. So what is happening over here, like above 50, the prediction model is directly giving us good prediction, but if you see below 50,000 salary person, the model is not giving us a good, like even for a salary person ranging from 40 and 50,000, he can also buy a car over here. But this perceptron model is not working that accurately, so that's why we are using sigmoid neurons over here. So the range of that prediction will be more smoother like this. So neural network are feed forward, that is they go from input layer to the output layer, but we can also train a model
Okay,
through.
so hold on, go back on the example, previous slide. Okay, now what sigmoid function is doing over here?
So sigmoid function gives us a range between zeros and one.
It's
So
activation function.
probability,
It's
yeah,
activation function, right? So sigmoid
yeah,
function is trying to really bring the non-linearity into the linear function, right? So
yes,
earlier you applied the linear function, which may be y equals to mx plus x1, m1 x1 plus m2 x2, right? Or
yes, sir,
w1 x1 w2 x2, right? Based
yes, sir,
on whatever the features you're taking, right? And it is a linear, but linear is giving you not linear is giving you linear outputs, but the buying pattern is not a linear. So in a to real world situation, you have to bring in some non-linear.
non-linear, yes,
So
sir,
non-linearity sigmoid function is trying to really bring the non-linearity into your output,
yes, sir.
right? Okay, move ahead.
So, as I was talking, neural network can also, we can also train the model through back propagation. Like we can send data from output to the input. Due to this, what will happen? The error, we can able to calculate the error associate with each neuron, and we can then adjust the weights accordingly to fit the parameter, and we can able to predict the output more accurately. So as we train the model, we need to evaluate the accuracy of how this model is working. For that, we usually use cost function or loss function, where we calculate the mean square error, where mean square error is this, the formula is over here, like 1 upon n, which is where n is the number of samples, and we do a summation of yi minus y hat the whole square, where y is the actual value and y hat is a predicted value. And as the mean square error is low, the model will be more accurate. And this mean square error is calculated through gradient descent technique, where each and every like output is calculated the mean square error, and it goes to the local minima, where when it reaches the minima, it's like calculate the mean square error over there, and the lower the mean square error over here, will get then best output. Then what are different types of neural network? So there are basically 3 4 types. Over here I have mentioned 3 of them: feed forward neural network, convolutional neural network, recurrent neural network. So feed forward neural network, it is also known as multi-layer perceptron, which has multiple inputs, hidden layers and an output. So basically, it is used for natural language processing, and it is more used in daily lives, or you can say over here we don't use perceptron kind of model, we use sigmoid, where the world use non-linear data, so we use feed forward. Generally, convolutional neural network, it is similar to feed forward neural network, but the thing is, in convolutional neural network, we tend to use more kind of pattern recognition, like image recognition. We over here use convolutional neural network, and recurrent neural network. It has a feedback loop pattern where it stores data and it is able to predict the future kind of thing. So, recurrent neural network, as the word recurrent, so it predicts. So this neural network can be used in uh, like the stock market prediction or weather forecasting, like things. And what are the small application where neural network has been used, like financial, healthcare, automobiles industries, and some of the derived application like facial recognition, stock market prediction, social media, aerospace, and healthcare. What are the cons of neural network? So as neural network, it is a black box. So what happens inside each node, we can't able to calculate at individual level and do calculation. So the calculation happens so intensely at the back. uh, the power consumption is too high for neural network, and the it is very expensive. As the power consumption is high, the CPU generates more power, and the it is more expensive. That's why. And for neural network, we also required more data to train it, so that we can get then accurate output, like that. So, and what is deep neural network or deep learning, we can say? So basically, in neural network, we have lesser layers, like less than 3 layers. Then it is called as neural network. But when the hidden layers, or there are multiple hidden layers, more than 3 layers, then the deep neural network concept comes around. And this is how it is different from neural network. Deep learning is different from neural network. Yes, sir. Thank you. Any questions, sir?
Yeah, Omkar, you said about neural networks are black box, right?
Yes.
Yeah, why it is black box?
So, as the diagram you can see over here, so the calculation happens in each node. It is very like for us, it is very difficult to explain what is happening inside each node, because we can, obviously, I have explained over here what is happening over here in one node in this slide. In this slide, what is happening over here in this one node, I have explained it. But if you see, there are like thousands of or hundred of nodes in deep neural network. We can see thousands or hundred of nodes which are interconnected with each other, and the
Mm.
calculation is very difficult for us to calculate each and every node. But due to mathematical calculation, for computer it becomes very easy. So that's why I'm saying it is a black box, because we as a human can't able to calculate each and every node and give you can get the answer. But machine